We're going to change topologies here as we take a look at OSPF passive interfaces in action. And as you can see on router 1, we have the fast Ethernet 00 interface running at 10.110/24 network there, and the usual 172.12.123.0/24 over our serial interfaces. This is one giant area 0. Nothing complicated here at all. And I want to give you a quick word about these passive interfaces before we see them in action and talk about why we would use them. Because occasionally you will hear people say, well, OSPF doesn't use passive interfaces. And even when I knew they did, I'm just like, well, why do you say that? Well, they always say, well, OSPF doesn't advertise routes the way, say, RIP and EIGRP do. And when you run passive interfaces with those protocols, you're, suppressing routing updates, basically. So since OSPF doesn't send routing updates per se, it uses the LSAs we talked about earlier, then you can't really use passive interfaces with OSPF. Now that sounds fantastic, sounds absolutely wonderful, and it's totally absolutely wrong. OSPF does use passive interfaces, and you're going to see a great use for them here. Now before we hit that, let me hit you with a real quick pop quiz here. Now I've checked pingability, nothing hidden here, I'm not trying to trick you, but here on router 1, I've got the commands here for OSPF, and I'm not using loopbacks here, so no worries there. But we have the network command clearly there, and it is clearly right, 10.1.1.0, and then a network mask of 0.0.0.255. Area 0, no area mismatches, anything like that. But I noticed when I went down to router 2 and tried to see the route, it wasn't there. And you know what's coming here on router 3, tried to see the route, it wasn't there. So what else could be causing that? And it's nothing tricky. I haven't done anything, wild or anything like that, any hidden OSPF commands that we haven't hit yet anyway. And it's the reason I'm bringing this up is that it's really easy, of course, to look at the last thing you did and try to troubleshoot that when something's not working. And that makes perfect sense. But here, the only thing relating to that particular network is that one network statement, and it's absolutely right. So maybe the problem is elsewhere. Maybe it's on the interface. And let's do a show interface serial, efast00. And you can see very top line is administratively down. And you might look at that and say, well, wait a minute, why did OSPF start if this particular interface was down? And the thing is, the 172.12.123.0 network, that's up. So OSPF was able to say, okay, I got an IP address to work with as a RID. Let's get started. So right now, first thing we're going to do is do a no shut there. The address was correct, 10.1.1/24. We'll wait for it to be up and then go check routers 2 and 3, and it should have that route. But that's just a reminder. It's a great thing always to check the last config you did for errors if something's not working, but don't get fixated on it because it could be something else. Let's go out to router 2, have a look. And there it is, and we'll go ahead and ping 10.1.1.1. And we'll do the same from 3. Should be fine, but we're going to verify. 10.1.1.1. And it's good. So we're rocking right along here, and I want to make very clear here that there's nothing technically wrong with this network. The passive interfaces are going to help us cut down on a little bit of traffic, but again, there's no technical issue here. But the thing is, the very act of running the network command, we know that enables OSPF on all interfaces whose IP addresses match that particular network statement, and in doing so, we're transmitting hello packets out those same interfaces. So that's a bit of a side effect right here, because right now router 1 off its fast Ethernet interface just sees a switch and just sees some hosts connected to that switch beyond that. So there are no devices downstream here that need the hello packets because literally we cannot form an adjacency on router 1. And remember how we take a look at the hellos and see what's going on there? Let's run another debug. We're going to run debug IP OSPF hello. Hello. And we're going to see some numbers here pretty fast. We see we received a hello from router 2 over the serial interface. Always watch that part. We just sent some hellos, and we just sent another hello. So I'm going to wait till one comes in from 3 here, and then we'll do a UAll for undebug all. And let's take a look at this and see why we care about this. Because Thing is, we're sending the hellos, and you see the unicast hellos to 172.12.123.2 and 3. We did that with the neighbor command. We're going to do that on the hub router in an NBMA network. But you also see the hellos being multicast out fast Ethernet 00 from 10.1.1. And the hellos are being sent to 224.0.0.5. I turned off the timestamps to make the debug output that much more clear. We know how often those are going out, right? Everybody knows that? 10 seconds. So if you're looking at that, you think, hey, it's just not that big a deal. But how many hellos is that over a longer period of time? Well, if you're looking at one every 10 seconds going out that's unnecessary, that means you're looking at 6 every minute, 360 every hour, and that would be over 8,600 hellos, I believe, 8,640, that 8,640 unnecessary hellos leaving an interface. And it still takes up a little bandwidth and there's a little work involved for router 1. So again, while this is not technically an incorrect configuration, we can definitely do something about it. We'd like to stop those hellos because we just don't want them going out an interface where it's totally unnecessary for them to go out. Now, we could do a couple of things to stop that. And one thing we could do to stop the hellos, of course, is just take the network command out. So if we run debug IP this hello here, and we'll let some debugs fly around a little bit. Gotta wait for those serial interfaces. How often is that, by the way? How often should we see hellos, that is? Every 30 seconds over our serial interfaces. So our dead time is 2 minutes. And we see a couple hellos being unicast coming out. Others will come in. There's one from router 3. But immediately we notice that we're not sending out any packets out fast Ethernet 0/0. Now, altogether, what's the problem now? We solved one problem. You know, the hellos aren't leaving that interface anymore. But the problem is, of course, when we took the network statement off, routers 2 and 3 now are not going to see the route because they're not getting any kind of information on that route, and you see now that it's gone. We'll hop over to 3, run the same command, and it is gone as well. So this solution is really not that great a solution. And let me do a UAll there, T router OSPF 1, and we will then put the network back in. And we'll zip down to 2. We should see that pretty fast. Not yet. A little too fast. There we go. And we'll just make sure router 3 sees it as well. Do a ping to 111. Doesn't hurt checking connectivity as you go along. So here's the situation. We obviously don't want to take the network statement out, but we really want to stop those hellos from going out that interface. And what we're going to do here is configure a passive interface. And again, the name is the recipe. It's going to be passive in that hellos will no longer be sent out that particular interface. But since you're not removing the network command, the route will still be successfully advertised to the other routers in the network. So let's go ahead and see that in action. And actually, I wanted to run a quick debug. And we'll run that hello debug again just to make sure we see the hellos going out. That shouldn't take too long. And there we go. There's the first one. We can go ahead and do a UAll there. So we know the hellos are going out that interface. So let's go to our interface. And probably IP OSPF. That was the priority, right? So we got process ID authentication, all kinds of other goodies here. Ignores MTA. Do you see anything here about a passive interface at all? I don't see the words passive interface. How about if we go with the process ID? That's just setting the area ID on an interface. That's interesting. I don't see anything about a passive interface there. It's actually somewhere else. So you hear passive interface, you think, oh, it's an interface level command, but it's actually configured elsewhere in the config, and we'll pick right up with that at the beginning of the next video.